All right, guys. So I just wanted to go through example 4 because I know we didn't have time to finish this in class. But it's pretty much the same as all the other ones. We just got a different shape we're dealing with. So it says a right circular cylinder. Okay, that just means circular, that the base of the cylinder is a perfect circle. So I'm just going to go ahead and draw that. All right, and so in a circle, we know that that's, right, the radius, and it's the same radius here, okay? And we've got a height. It says the height of it is 10 feet, so that makes this h10, and a radius of 9, so we'll do 9, right? Sorry, 8, my bad. Whose dimensions are changing, so that means the height and the radius are changing over time. Write formulas for the volume and surface area. So surface area, again, is just all the stuff on the outside. So all this stuff on the outside, around it, and at the top and at the bottom, okay? And the rates at which they are changing. So rates, again, we should be thinking derivative. Okay? So let's take our volume formula. Volume of a cylinder is pi r squared h. And again, pi r squared, that's just the area of a circle. And then when you multiply it by its height, right, you get this volume. So that might be a good way to remember that. And then we want to find the change of volume, okay? So that's going to be the derivative. So if we take the derivative of v with respect to time, it's the derivative of v is 1. And then with respect to time, dv dt equals. And then we've got the product rule that we have to apply here, okay? So we've got r squared as one function and h as the other, where pi we can just leave on the outside and worry about that at the end, okay? So if I go ahead and do I'll do it down here, my product rule for this, I'm going to get, if my f function is r squared and my g function here is h, I'm going to take the derivative of this r squared, and it's always with respect to time. So using the power rule, 2r times dr dt. That's the with respect to time piece. And then we've got h, the derivative of h, again with respect to time. It's 1, but we're not going to write that, and then dh dt, okay? And so if we go back up here, and what we want to do is multiply our f times f prime times g, g prime times f. If I write that, and I'll just do it right here so we can have it all together, it'll be 2r dr dt times h plus r squared dh dt, okay? And so I'm going to go ahead and put that back up here with our pi. So 2r dr dt times h plus r squared dh dt, okay? All right, there's our change of volume. Now, if you decided to distribute this pi in, that's fine. Or if you kept the pi somewhere in your product rule, you should still get the same answer. All right, now we're going to do surface area. Surface area formula, we're going to use S to represent that. It's just going to equal 2 pi r squared, okay? And that's just the pi r squared. That's just the base, okay? And then since there's another base up here, that's the second part of it, right? So that's why there's 2. Okay, so that's the area of those two circles. Plus, we're going to do 2 pi r h. And again, 2 pi r, well, that's just the circumference of the circle times its height. That's going to give us this rectangle that's looped around here, all that outside piece. Okay. So there's our surface area formula. Now, it might be best to memorize the surface area and the volume formulas, but you can derive the change formulas, okay? So we're just going to take the derivative. So again, we're taking the derivative of s with respect to time. That's going to be ds dt. equals, and then power rule, 2 on the outside, 2 times 2 is 4. So that gets us 4 pi r, but again, with respect to time. So dr dt plus, and then we've got this right here, which again, it's r and h being multiplied. So we're going to go ahead and do the product rule again. So I'm going to leave the 2 pi on the outside. And just for the purposes of time, I don't want this video to get cut off. I'm just going to put in the product rule, but we'd follow the exact same thing we did over here, okay? And so what we'll get is dr dt times h plus r dh dt, okay? And so there are all our formulas. So now from here, we just have to figure out what's given to us, write it in math language, and then plug in to all these. So it says the radius is growing 2 feet per minute. That means that if it's growing, it's going to be positive, and it's the radius that is changing. So this tells me that dr dt, so the rate at which the radius is changing with respect to time, is going to be positive 2 feet per minute. Okay, and then similarly over here, it says that the height is shrinking at 3 feet per minute. So we should know shrinking means negative, okay? And the height is what's changing. So this tells me that dh dt is going to equal negative 3 feet per minute, okay? And then from here, we want to find the change of volume. All right, well, that's just this formula. So dv dt is going to equal pi times 2. Now, r, right, from this formula, we already know. That was given to us right at the beginning. So r is going to be 8. dr dt, okay, that's what they gave us right here. It's a positive 2 times our h, which again, they gave it to us at the beginning, 10. Okay. Plus r squared, so plus, again, our r is 8, so 8 squared times dh dt, right? dh dt is this rate right here. That's negative 3, okay? And we can close that parenthesis, and if you go ahead and solve that all the way out using proper algebra, we should be getting 128 pi feet cubed per minute. Now it's feet cubed because this is volume, okay? And so that would be our answer here. Okay, change of surface area, we're doing the same thing using this formula. So this is a little bit longer. Might have to go on to the other line, but we'll see if I can fit it. 2 pi r, our radius is 8. dr dt, again from the problem, said it was 2. Plus pi, 2 pi, sorry, parentheses, dr dt, so that's our 2 again, times our h, which is 10, right? Okay. Plus our r, oh, yep, which is 8, times dh dt, which we have as negative 3, okay? And so if we again go ahead and solve this out, we'll get a ds dt of 72 pi feet squared per min, okay? And you can leave it in terms of pi. It's a little prettier, easier to read, okay? So we'll go ahead and do that same thing for this. Radius decreasing 4 feet per minute. All right, well, that just means that now this is going to be negative 4, right? And that's saying that now our dr dt is negative 4 feet per minute, all right? And then our height is increasing at 2 feet per minute. So that tells us that dh dt is going to be 2 feet per minute, positive, okay? And then we just plug in the same way that we have been doing. So change of volume formula is right here. We're going to do pi times 2 times our radius, which has not changed, okay? Our actual radius is still 8, our original, and then dr dt now is negative 4 Okay. Times our height, again, that hasn't changed, that's 10, right? Plus r squared, so that's 8 squared, okay, times dht, which they gave it as 2 in this problem, okay? And again, we go ahead and do that out. We'll get dv dt equals negative 512 feet cubed per minute, all right? All right.